Hello, this is your fifth construction in the series in G4, and this construction is called an angle bisector. So the goal is to take a given angle and to cut it in half with a bisector. This list of how-to is your paper copy of your notes, and I'm going to follow these directions as I work with the digital tools online. I need to move up to section 5 in your online notes named G4 Notes Constructions. So section 5, we are working on building angle bisectors. Okay, so step 1, place the compass on the vertex of the angle. Draw an arc that intersects both sides of the angle. Okay. Grab the compass, put it on the vertex of the angle. Draw an arc so it intersects both sides of the angle. Step 2, place the compass on point X, which is one of the sides of the angle. Draw an arc in the interior of the angle. The compass on one of the intersections. Draw an arc in the interior of the angle. Step 3, without changing the radius, place the compass on point Y, which is the other line, and draw another arc. They shall intersect out here in the interior of this angle. So switching over here, not changing the radius of the compass. Draw another arc so that you have an intersection in the middle of the angle. Final step, use the straight edge to connect the two, to connect those 2 points. Switch to the straight edge, connect your intersection to the vertex, and we have split this angle in half. All right, let's practice an SOL multiple choice question. Which point produces the angle bisector of ACB? All right, let's get the compass, set it up on the vertex. Step 1, draw a line or draw an arc that intersects both sides of the angle. Now I've made my compass as small as possible. Let's try again. Let me make my compass as small as possible because this is a pretty small picture. Yeah. Boom. Now, step 2, place the compass on X, which is on one side of the angle, and create an intersection arc out in the interior of the angle. So I'll start over here. Create an intersection arc in the interior of the angle. Now do not change the radius size of the compass and create another intersection arc off the other side of the angle. You're finished with the compass, so switch over to the straight edge, and if you connect the vertex through that point of intersection, you will have created an angle bisector. Our angle bisector cuts through point E. Okay, here's another way they could present angle bisector style constructions. It says, what type of construction is being illustrated in the figure? So they have not finished this construction. They've done a couple steps and they want to know, what are we building? Okay. Is it the bisection of angle D? If you were to use the straight edge to connect angle D to the point of intersection, would it bisect that angle? Sure would, cuts it right in half. So I think we found our answer with A. Let's go through a couple other options here just to make sure we understand. The bisection of side BD. Well, side BD is a diagonal. And if you were to bisect a side, you would have to cut that side right in half. So we'd be looking at something that cuts through the very, very middle of BD. So that's just all kinds of mess. That's wrong. Take that out. Finally, an angle congruent to angle D. Well, again, if we make our final connection, we have made two congruent angles, but both of them are much more skinny than angle D. They are not congruent to angle D. So that one's out. And then finally, a line segment. Obviously, we're not dealing with a line segment because we've used this angle arc to start our construction. All right, so that was our practice on angle bisectors. We have one final video after this, so come back for that, and happy studying.